membership portal is on the screen. It's Amazon. And please check out this link tree over here. It contains all of the slides, the feedback form, the Python tutorial, etc. And join our Discord if you have the idea. I'm going to give you a minute to take this link down. And if someone could post that in the chat, that'd be great.
How do you?
Thank you so much. Like what?
Please post the link tree.
Okay, can I copy the link? I cannot copy the link. All right, cool. Hopefully everyone got access to the slides. I'm going to start moving forward. So a quick intro to us at ACM AI, in case you couldn't make our GM or the ACM GM. Our mission here is to build a community of students at UCLA interested in AI. So we host various events, various initiatives to further that cause. So our values, well, we want to create technical proficiency. We want to know a lot about the math, the coding, everything about AI. We want to have a positive impact on society as well. We host a lot of events on climate change, on diseases, and we try and have as much of an impact on society as possible. And of course, we really want to keep diversity and inclusion in mind as well. So our various initiatives, right now we're hosting a workshop that comes under our workshops subcommittee. We host various workshops throughout the quarter on machine learning, deep learning, really try and get technical about AI. We also host various one-off events, like a research panel about getting into research in AI. Again, like I mentioned, like climate change in AI. We're going to have an event about COVID in AI later this quarter. So definitely look out for that. We also have an outreach program where we actually go to high schools in LA and teach the high schoolers about AI. And we also have a podcast where we interview professionals from the industry about their experiences. We also have a projects track where we take up a project every quarter and essentially build it up from the ground up, like computer vision projects, and hopefully in the future, other topics as well. So we have a lot going on in ACM AI, lots of opportunities to be involved, and yeah, we have a lot of fun doing it. So our workshops, this quarter, we are having two different workshop tracks, a beginner track and a advanced track. This is the beginner track series where we cover the basics of machine learning. And we're going to implement a lot of the basic models like linear regression, logistic regression, k-nearest neighbors. And these are kind of the foundational models that then go on to build much more complicated things like neural networks, which is what we discussed in the advanced track. So advanced track covers deep learning, a lot of the cutting edge, state-of-the-art stuff that we do, like CNNs, RNNs. And advanced track, of course, requires that you have this basic knowledge of ML. So yeah, those are our workshops. And let's talk a little bit about beginner track. So beginner track is meant for people who have no prior experience in machine learning. You don't need to know anything about it. We want it to be an introductory course. As long as you have some minimal experience in coding in some language, you should be able to follow this pretty well. And we're actually going to be teaching you a lot of the coding during this series. We're going to be having a workshop on Python at the end of this session itself. And beginner track is mainly for those who really want a strong foundation in the theory behind ML. We feel like what often happens is you read a blog post online, an article online, and kind of jump right into the implementation, just use a library function and get something running. We kind of want to peek behind that curtain and get an understanding of what happens with the math behind AI, how it actually works under the hood. And yeah, so we're going to cover the basics of machine learning. We're going to cover the theory and the implementation of some of the models. Like I mentioned, it's going to be linear regression, logistic regression, k-nearest neighbors. And we are going to introduce you to really cool, really powerful ML libraries, the stuff that's used all the time, every single day in research industry. And of course, while we are online at UCLA, we're going to be meeting on Zoom, Thursday, 6 to 8 p.m. So to quickly introduce ourselves, we have 4 instructors for beginner track. My name is Sudhanshu Agrawal. My pronouns are he and him. I'm a third-year CS and Math double major here at UCLA. Jensen, do you want to go next?
Yeah, my name is Jensen. I'm a third-year computer science major. My pronouns are he and him, and I'm going to be helping out with beginner track this quarter.
Hi, I'm Claire Hong. I'm a first-year CSE major. I forgot to put my pronouns down, but they're she, her, and I'll be helping out as well.
Hey guys, I'm Naman Madani. My pronouns are he, him. I'm a first year CS and Math double major, and I'll be helping out with beginner track as well.
Yeah, awesome. So yeah, we're super excited and hopefully we're gonna have a great quarter. So our schedule, this is the very first workshop, Intro to ML, and the second half is going to be an Intro to Python. So if you aren't comfortable with Python, this is your chance. This is going to be a really quick introduction, and we're gonna get you up to speed. Then the next few weeks, we're gonna get into the meat of stuff: k-nearest neighbors, linear regression, logistic regression. Our three favorite models, and we're gonna cover all the cool words you've heard about before, like gradient descent, optimization, all that kind of stuff. Then we're gonna, in the second half of the quarter, is gonna be more implementation heavy. We're going to talk about NumPy and Pandas. Those are the 2 libraries that I was talking about, which are super, super powerful, super commonly used everywhere. And the last 2 workshops are going to be kind of special. We're going to have guided mini projects. So what we're going to do, we're going to take our classic ML models and implement them from scratch in Python. So it's as good as implementing one of those library functions from scratch. And our objective is it is a accumulation of all the stuff we've learned and should really solidify all those concepts. But yeah, that is our schedule for this upcoming quarter. And before we get started, a quick disclaimer: don't worry, ML sounds a little daunting when you first get into it, but our objective here is to get you as comfortable as possible with everything that we do. And yeah, so before we get into the content, are there any questions about the schedule, about the course, anything else? How many sessions are there in this track? So we're aiming to have 7 or 8 sessions. We have that buffer in case something happens, there's a big event or we miss a workshop for whatever reason. But yeah, 7 to 8. Any other questions?
I presume that the lecture videos would be posted on Discord, right? On the videos?
Yeah, so actually we'll post the videos on YouTube, and we'll definitely post the links to that on Discord as well. Cool. I think we can get started, and I'm going to hand it off to Naman.
Awesome. So before we get started, we've all heard of artificial intelligence and machine learning and all these big buzzwords. But for us as beginners who are starting out for the first time, what do you think are the most common uses and the most common applications of AI and ML in real life? Where have we seen this? I'll give you 10 to 15 seconds. Feel free to drop it down in the chat below or unmute and answer. Awesome. So yeah, we like YouTube, which is definitely one of the users, TikTok. I mean, all of these things are algorithms which are built through artificial intelligence and machine learning. You look at, okay, we have some excellent answers here. And we'll move on. So Danshu, if you could move the slide. Right. So I want to talk about some of the most important, some of the most up and coming, some of the best applications of machine learning. So some of you, I think Mark mentioned Tesla. And Tesla really ties into this idea of computer vision. Now, what is computer vision? Computer vision is basically using computers to derive some sort of meaningful output from digital input. So you give in images, you give in pictures, you give in videos, anything of that sort. And we run a machine learning model and it can identify what's going on in the picture or the image or whatever the desired input is. So computer vision often ties in, and we talk about Tesla, we talk about Uber. Some of you might know about Lyft as well. And one of our star professors, one of our best professors here at UCLA, Kerry Natchenberg, who some of you might have heard of, actually worked at Lyft, and he worked in the sphere of electric vehicles. And many of you might have actually seen the video of a Tesla driving around Silicon Valley, identifying everything in its surroundings. And frankly, that is one of the best applications of ML, and it's frankly going to restructure humanity as we know it. Moving on, the second best, Sudhanshu, if you could just, yeah, awesome. So healthcare. When we talk about healthcare, some of you might have heard of a lot of new research studies in the news about how professors at Yale and researchers at Yale have come up with this machine learning model, which can actually take in MRI scans at hospitals and identify and tell us whether or not there's rare neurological diseases within them. And we've realized that healthcare, and when you put in machine learning into healthcare, you actually often outperform humans itself, humans. So when you actually look at it and you see that a team of 6 radiologists can't beat one of the machine learning models that we've constructed, it's honestly mind-blowing, and it's one of the spheres where AI is up and coming. Moving on, we have natural language processing. Natural language processing, some of you might have heard of OpenAI. And there's a very popular story about this, about how a college student like you and me actually ended up developing, he used OpenAI's GPT-3 model, which has been constructed of billions and billions of data points, and actually published a blog which was written by artificial intelligence, not humans. And that blog went on, and it was posted to I think it was posted to one of the most popular news channels. I think it was Hacker News, but it reached the top within the few days, and nobody could tell till it was publicized that it was not actually written by humans, but it was devised completely by artificial intelligence, the entire blog post. Yeah, so those are the most common uses of machine learning. Now we're going to move in, and we're going to play a game, and we're going to try and understand some of the intuition behind machine learning.
Awesome. Yep. So the next section is about getting some intuition behind ML. And to do this, we've come up with this, let's say, game, which teaches us a bit about how this might work. So the game is what we call 50-50, right? It is something we came up with over here at ACM AI. So let's see how it goes. And it's worked pretty well in past quarters, so we're pretty hopeful. But here's how the game works. So all of you here in the audience, let's suppose we took all of the names of everyone here, put them in a list, and our objective is to find the letter such that 50% of your names come before it and 50% come after it. So let me repeat that. The objective is to find the letter of the alphabet such that 50% of the audience's names come before this letter and 50% come after. So, those of you familiar with it might recognize that this is kind of the median starting letter, right? So it's just finding this, 50% boundary. And the way we're going to do this, we're not going to do any statistics. We're going to do this in let's say, an ML sort of way, a high approximation of ML, but it should give you the kind of intuition about how it works. So the way we'll do this, we'll start off by choosing a completely random letter. And every round, the audience is going to vote. The audience is going to say, the first letter of my name comes before this letter, after this letter, or is the current letter. So suppose the current letter is the letter B. My name is Sudhanshu, so my name comes after the letter. So that's how I would vote. So it's gonna make a little more sense once we actually start playing the game. But does anyone have any quick questions before that? Okay, I think we are good. So yeah, let's get started then. if all you could scan this QR code, you can play the game on your phone. It's essentially going to take you to a polling app that you can vote on. And yeah, please let me know if there's any technical difficulties with the app. Yeah. If the QR code doesn't work, please just use the link in the chat. And yeah, let's not start voting right now, but it's good to know that it works. Let me reset the results. And I am going to share this slide. 1 second. Okay. Can everyone see my screen, the new screen that I'm sharing? Yes, no, thumbs up, thumbs down. Yep. Okay, great. And it's I'm guessing it's clear enough. So let's get started. I'm going to start off with this really random guess for what that median character should be. Okay. I'm going to say it's the letter V. Okay. Now, I want everyone to vote. Does your name come before, at, or after? Okay. I'm going to give it a few more seconds. Hopefully you guys can see the results as well. It's highly skewed towards before. Okay. Any last minute votes? 10 more seconds. Okay, I think we're good to go. So as you can see, the poll is telling me that the actual true answer is way before this current letter. It's like a 90% swing. So, I'm going to take a huge step. I'm going to go kind of all the way up to, I don't know, the letter D, for example. Now, don't vote just yet. Let me reset the results. And let's go. Let's vote again. The letter D. What do you guys think? Whoa. Okay. So we're doing a little better, right? We were like 90-10. We're like 30-70 now. Way better. Genuinely way better, right? And we're getting that. I'm going to give it like 5 more seconds. Okay. Now, let's ask a question here. Can anyone tell me, should I go up or should I go down? Let's type it out in the chat. Should I go up or should I go down? Okay. Great. I'm getting a lot of downs in the chat, and that's absolutely right? The poll is telling me that the true median letter should probably be somewhere down. So let's take another swing, right? Let's go to the letter N. Okay, let me reset the poll. Don't vote just yet. All right, go for it. Okay. Okay, very cool. Ooh, I think we went a little too far down. All right. So real quick, up or down? Perfect. Yeah, you guys are really getting the hang of this. So yeah, we need to go up again. So I'm going to go a bit up, let's say to the letter H. Let me reset the poll. And let's vote. Okay. This looks promising. I think we're almost there. Okay. 60-30. I think we can nail this with 1 or 2 more. Okay, 60-35. Very cool. Let's do 1 more. As we know, we need to go down. So I'm going to pick the letter, let's say K. Okay, reset the results. All right, let's try this once more. Okay, 55-40, 50-40. Ooh, I think we know what the answer is going to be. What do you guys think the answer is going to be based on what's left? We're at 50-40, which is pretty great. We see some J's, we see some, okay. I say we'll give it a shot. Let's try the letter J. I'm going to zoom in. And I'm going to reset the poll. Okay, letter J. What do you guys think? Okay, I think we're getting there. Any more votes? Well, I think that's pretty close. All right, so as you guys can see, we've got a pretty close answer here. Obviously, we couldn't expect it to be exactly an exact split, but somewhere between J and K is that median letter. We've got pretty close with 39, 13, and 48. And yeah, that's kind of been our game. So we started off with something completely random here. We started off with the letter V, right? We've performed several steps based on some data and got to a much, much better answer with a much lesser error. And yeah, that is our little game. And the kind of purpose of this is to show you how ML would kind of iterate and improve its results using data. That is the message we're trying to drive home here. This kind of oscillatory curve is similar to what happens in ML with the model taking steps to do better and better. Okay, anybody have any questions about this game? If there are no questions, then I think we can move on. Okay, great. Claire, you want to screen share?
Yeah, you need to unshare your screen first.
Gotcha.
What can you see right now out of curiosity?
The QR code?
Okay, got it. Then we present. All right, so now let's get more in depth into what exactly is machine learning. For your benefit, we have a meme here. I hope you enjoy. So you heard the term artificial intelligence and machine learning earlier today. Some of you might have heard of the term deep learning. Now, to situate what these terms mean in regards to each other, we can think of AI as being this sort of overarching philosophical concept of which machine learning is a subset. Now, similarly, deep learning is a type of machine learning, so it is a smaller part in AI as a whole. Now, to get more specific, as I just said, artificial intelligence is sort of this concept, but what it actually means is it allows computers to perform tasks that normally require human intelligence, such as seeing, hearing, moving, or decision making. Now, when we say hearing, or moving, we don't just mean that this computer just takes in pixels or values, but what we actually mean is that the computer is able to assign a meaning to them or detect some sort of pattern. Now, machine learning, as we just discussed, is a type of AI, and it entails how computers can now start to see patterns and perform artificial intelligence tasks without being explicitly told to do so. So let's discuss. Let's say that we wanted to predict how much a dorm room was. How would you go about it? Let me figure out how to pull up the chat. There you go. If anyone has any ideas, you can just throw them out right now.
You should look at the previous price of all the dorm rooms, and then collect data on like their size and their location and stuff.
Yeah, that's a good idea. Anyone else? Demand, that's a good one. I'll give it a couple more seconds. Location, number of beds, utility prices. Those are good things to look at. All right. So thank you for contributing your ideas. So what you've actually been thinking about is kind of like a model. So what is a model? It's something that takes in an input and produces an output, such as takes in a picture and looks at whether it's a cat or a dog, takes in a sentence and translates into French. So in this case, our desired goal would be to have something that takes in this particular dorm room and gives us a price that it might be. So a model would be pretty helpful in this case. And how do we create models? Well, we create models through machine learning, through a process called training. So now that we've talked a little bit more about models, we can start to think about how to apply it to our problem, which is how will we predict dorm pricing with a model? So some questions that we might ask ourselves is, what would our model take in? Basically, what would you need to tell how expensive a dorm room, which is, you guys have already said a lot of stuff about that. And now what would the output of our model look like? There are different kinds of models, and we can consider if we want it to be a continuous model, which looks slightly more like a graph, or would it be categorical, which is referring to like this or that? Does anyone have any ideas? Continuous? Actually, yeah. Continuous would be helpful for, I would say, looking at the price of a dorm room through time, which is a valid statistic that you can use. But yeah, continuous is actually an option for this, I think. So now let's look at how we would actually go about making a model like this. So we have something called a machine learning pipeline. And so this is kind of a simplified version of how you eventually end up with a model. So as we discussed before, we could feed it in data, which is like similar dorm room prices or similar dorm rooms of size or how many beds there are. And then we would train it, which is we would feed it into some code that would look at the patterns in the data and eventually is able to draw inferences, which is when we're able to apply the model to real world data. And now I'll hand it off to Naman.
So let's talk a little more about the intuition behind, machine learning and artificial intelligence in general. Let's think about a problem from our childhood. When we were actually seeing things around us, beginning to observe, how could we tell the difference between a cat and a dog? Like, feel free to put it down in the chat below. But when I broadly think about it, I know that a cat has a tail and a dog has a tail, but that they have different types of tails. Maybe a cat has longer whiskers than a dog, and maybe the cat is more furry than the dog, or maybe the dog is more furry than the cat. That depends on the kind of animal we're looking at. But in short, when we talk about a cat and a dog, we're trying to look for differences in their structure, for differences in the way that they not only look, but in the way that they sound and how we observe them. So when we actually start out trying to distinguish them, we look at certain things. We look at certain aspects in a dog and a cat, and maybe they're differing, maybe they're not. But say I look at a dog and I see that it has a tail, and that's all I know because I'm a child right now and I don't know the difference between dogs and cats. So right now I look at a dog, I see it has a tail, and I've only seen a cat before, and a cat also has a tail. So I classify the dog as a cat. I go tell my mom, look, that's a cat. But it's not a cat, it's actually a dog. And just like that, slowly your parents and your teachers and the people around you correct you, and you keep becoming more and more accurate. So how it works is we look at very, very small things, very, very objective data between cats and dogs. And then after we look at the broad picture, we can identify a certain animal as a dog or a cat. Now, moving on to the next slide, that's sort of how machine learning in the real world works is too. So what we do is we take labeled data, we run our model. So what we do in machine learning is basically training a model. And in the model, we feed the model millions and millions of data points. And these data points are basically labeled. So I give in a picture of a cat or a dog, and I tell my model that this is a cat or a dog. So it looks through multiple instances of cats and dogs, and it slowly starts identifying what the difference between a cat and a dog is. And the more information we provide, the further we go. Now, some of you might have this question: who exactly labels this data? And frankly speaking, as of now, humans are still the ones labeling the data. Some of you might have heard of the Amazon Mechanical Turk, which is a data labeling service by Amazon, where Amazon actually pays you. Don't worry, we won't be able to make a living off it. It doesn't pay a lot. But the Mechanical Turk actually has people like us who work, or maybe even Google's CAPTCHAs, right? That's how all of this works. We identify the data for them, and as a result, their model keeps getting trained. So like this, the AlexNet was built. The AlexNet was the first huge image classifying architecture. And it was trained on, again, millions and millions of photos. And this was built in 2012, which is 10 years ago now. But yeah, so that's how this works. And if you're genuinely more interested in studying about the AlexNet, about how machine learning actually is able to classify images, I would recommend reading this paper, which we've attached. And the slides, of course, are available via the feedback form. That's it. So our main objective of this workshop was to introduce ACM AI, to talk about machine learning and the things we might have heard in our day-to-day life. And now we're going to have a small Python tutorial. So throughout this, we'll be using Google Colab, and it has a lot of packages which are helpful, which will be extremely helpful throughout this course. And apart from that, we also recommend using the Anaconda distribution. Of course, it isn't required here, but it's one of the most popular software distributions within the data science community. And for an intro to Python, we're going to take a short break here. We're going to wait off for 5 minutes, but this is a very, very quick intro to Python. And it's primarily for those who haven't used it before, or from those who want to hop on from a different language to Python. And frankly speaking, it's going to be very rudimentary. So for those of you who would like to leave right now, you can, and we'll see you next week where we'll be studying k-nearest neighbors. But yeah, that's it for now. We'll take a 5-minute break. And if you have any questions, we'd be glad to take them. And then we'll hop on to the Python module. I'll link the tutorial below in the chat.
So for our Python portion of the workshop, we're going to be covering list, for loops, if-else statements, and functions. So if you're familiar with those concepts in Python, then feel free to leave right now. Otherwise, we're going to restart in about like 5 minutes. So we're going to be going over a list, for loops, if else statements, and functions. So if you're familiar with those concepts in Python, then yeah, this portion is probably going to be pretty basic for you. So you can feel free to leave. But yeah, it should be pretty short. I know it's getting kind of late, so I'm gonna make this pretty quick. Yeah, I think the Zoom link should be the same as long as we're doing this virtually. Is there a link to the presentation? Yeah, so the link for a presentation should be in the feedback form. Yeah, so it's the first link. All right, we're gonna restart. All right, so the next part of this workshop is just gonna be like a really basic introduction to Python. I'm gonna assume you guys have like zero prior experience for programming. So, all right, so I guess as to how this portion of the workshop is going to work, so I'm gonna be doing like a live demo of Python in Colab. So you guys can either follow along on the screen, because I'm gonna be asking you guys some questions later on, or you guys can make a copy of the skeleton notebook and play around on your own. So either option is fine with me. I'm gonna give you guys maybe like 30 seconds to make a copy. And if you guys have any questions at any point, feel free to ask me. Either speak up or type in Zoom. I'll try to get to every question in the Zoom chat if I can. All right, so hopefully everyone has made a copy of the notebook in their drive. So we're gonna start with talk about how do we perform math operations on integers and floats. So hopefully this should be pretty familiar for most of you guys. So I guess something to note here is in Python, division by default is floating point division. So if I divide 3 by 4, then I get 0.75. So if we want to do integer division, we have to use the double slash. So that's something that might be not familiar if you guys come from a different language. Okay, is there a question in chat? Okay, never mind. So coding doesn't really get interesting until we have a way to like store information in our program. So this is when variables actually come in handy. So to create a variable in Python, I can do x equals maybe 1. And so this would assign the value of 1 to a variable of x. And I can reuse x later. So if I want to like add 1 to x, I can do x plus 1, and this would give me 2. I can also use the same math operators on 2 variables. So if I give y the value of 2, then x plus y would give me 3. And so something important in Python or Colab notebook specifically is that the notebook actually preserves the states of your variables. So if you try to run this next cell, so if I run it the first time, notice how I initialize x to the value of 1, and now I'm incrementing x by 1. So this would give me the value of 2. So what do you guys think will happen if I run this cell again? What would be printed? Feel free to speak up or answer in chat. Okay, Caitlin suggested 3, so let's try to run this. And yes, we indeed get the value of 3 because remember last time the value of x was 2, and then we increment this again and we get 3. So something that could trip people up in Colab is that like cells do not have to be run sequentially, like from top to bottom. So in theory, I can run this cell and then I can run this cell again. And now x plus y would be 5, which might be confusing if you're reading the code from top to bottom. So yeah, this is something that you should keep in mind. And so actually now I have a question for you guys. So if I want to store my name in a variable, like what should I do? Variable, should I do? Any ideas on what data type we should be using? So the answer is we should use a string variable or a string data type. And the way we would initialize a string is enclosing it with either single brackets or single quotes or double quotes. So here I assign smallberg to the value of name, I get smallberg. If I use double quotes, this also works. All right. So now that I store, now that I store my name in a variable and I want to like display it on the screen, what should I do? Display my name on the screen. And I guess to do this, we can use the print function. So if I pass in my name into a function, then it would print out the string that is stored in the name onto the screen. I can also pass in multiple strings into print. So if I say, if I pass in my name and is funny, so this will actually print out smallberg is funny. And I can also pass in integers or other data types to a print statements. So if I do name is X years old, this would print out smallberg is 3 years old. All right, hopefully you guys get the idea. Okay, any questions? If not, I have another question for you guys. So if I want to store more than a single value in a variable, how would I do that? I'll let you guys think about it for a little bit. All right. So there's actually a very useful data structure in Python called a list that allows us to store more than one value in a single variable. So if I want to store the value like maybe 1, 2, and 3, so instead of like making 3 separate variables, I can create a single list. That's the value 1, 2, and 3. And also add some more values. So this is how I initialize a list in Python. I can also have like, I guess, mixed data types in the list. So I can have an integer, a string, a floating point, and maybe even a Boolean value. And so this will work. And something that I can do to a list after I created it is to append something at the end. So if I append 6 to the list L, I will get 1, 2, 3, 4, 5, and 6. And similarly, I can also pop a value from the end of the list. So if I do list.pop, I will basically remove
I think Jensen's internet cut out for a second. Let's give him a sec.
Okay, sorry, my internet is crashing on me.
All good. Dorm Wi-Fi, huh?
Yeah. Dorm Wi-Fi is kind of sus. Okay, so now that we create a list, so how do we access values in a list? So I'll let you guys think about this for maybe like 10 seconds. So the answer is we can use square brackets. So if I do L square brackets 0, this would return the first element in my list, which is recall 1, 2, 3, 4, and 5. And something to note here is that the indexing in Python at least starts with 0. So if I do something like L square brackets 2, so actually, like, what do you guys think this would return or print out? Feel free to answer in chat or speak up. Okay, Mark answered 3, so that's correct. This would run. So yeah, by indexing into the index 2, I'm getting the third element in my list. And so what if I try to get like index into the 5th index of my list? So what does this return if it even runs correctly? Feel free to answer in chat or speak up. Okay, so yes, this would create an error because our list only has 5 elements right now. And then by indexing to index 5, we're looking at the 6th element in our list, which doesn't exist. So Python is going to give us an error. And so another interesting thing to consider is what would happen if we pass in negative indexes into our list? So what would happen in this case? Feel free to answer in chat or speak up. Okay, so Caitlin says it goes to the last item in the list. And if we run this, it does return 5. And so this is the same as indexing into the length of our list, -1. And in Python, we can just drop the first part and the compiler would understand that we're trying to get the last element. So this is kind of like some syntactic sugar that is specific to Python. If you try to do this in another language like C or C++, this would give you an error. But yeah, this is just something interesting about Python. All right, so I have another question for you guys. So how do we get more than one element, or how do we access multiple elements in a list? So specifically, recall that our list is still 1, 2, 3, 4, and 5. So if I want to like print out like 2, 3, and 4, like how would I do that? Is there a way for me to get just like the middle 3 elements of my list? So the way that I can do this in Python is using something called list slicing. So if I want to get 2, 3, and 4, I can pass in square brackets the number 1, and 4. And so the way that slicing in Python works is you pass in like a starting index. So this would return elements in L starting at index 1. So that's the second element, and then up to, but not including the item at index 4. So in Python, we can actually drop one of the numbers. So I just passed, if I drop the first number, this would return all the numbers starting at the beginning of the list and up to, but not including the item at index 4. And if I drop the second element or second number, this would return the elements in the list starting at index 1 and up to the end of the list. So yeah, this is how slicing works in Python. So any questions? All right, if not, we're going to be going to if-else statements, which is useful when you're trying to execute code blocks like conditionally. All right, so I actually have an interesting question for you guys. So how do we express the notion of if it's raining, then bring an umbrella? So how will we actually express this in code? And I'll give you guys a hint. I will need a variable called it's raining, which is a Boolean value. So I'll initialize it to true. I'll let you guys think about this for maybe like 30 seconds. You may try to come up with this on your own. So in Python, we can use if-else statements to execute some code if a condition is true. There's actually an answer in chat. So if it's raining, bring umbrella, else don't. So yeah, that's a pretty good answer. I'm gonna be, yeah, so I think the solution that I have in mind is pretty similar to what you typed. So we can do if it's raining, then let's just print out like the statement bring umbrella. And so if I run this, bring umbrella would be printed because it's raining is true. So this is equivalent to saying if it's raining is double equal to true. So something that is confusing that might be confusing is why there's a single equal here and a double equal here. So in most languages, single equal means assignment. So here I'm assigning the value of true to the variable is raining, whereas here I'm comparing the value of is raining to the Boolean value of true. So because it's raining is true, so I would print this following statement. But in most cases, we can just omit the double equal to true part, and this would work. And I guess my follow-up is if it's sunny, then we should bring sunscreen. So how do I express this, adding to what I already have? All right, so Jim suggested in the chat that I should use an elif block. So let me go ahead and do that. Actually need another variable. I'm just gonna call it is sunny. Initialize this to true. And then I'll just set it's raining to false for now. So else if it's sunny, then I bring or put on, bring sunscreen. If I run this, I would get or evaluate the second code block here. And I guess for completeness, let me just write the else block. So in this case, I'm just gonna say it's cloudy. And if both of these are false, then I would trigger the else block. And also note that like the statements within each of these if blocks are indented by 1 in Python. So this is something that you should pay attention to. All right, hopefully that's pretty clear. I have another example for you guys. So how do we express the notion that if I have swipes left, then go to or eat at the study. Otherwise, get Panda Express for dinner. I'll let you guys think about this for maybe like 30 seconds, and then we'll go over the solution. And also we'll need a variable called like number of swipes. Set to 1 for now. All right, hopefully you guys have all come up with the answer. So the answer that I have in mind is if num swipes is greater than 0. So that means I still have swipes left. Then I print grab a study sandwich. Otherwise, I should print out Panda Express. So if I run this, I'm going to get a study sandwich. So what I can do here is I can also decrement the number of swipes. So I run this, then now I have no swipes left. So I run this again. Okay, what's going on? Is there a typo?
We
never mind, I'm
reinitialized
setting
num
this
swipes.
to 1 right now. I should have put this in the earlier block. That's an oopsies on my part. Okay, so if we do it like this, then now I've had no swipes left, so I'll have to get Panda Express for dinner, which is kind of sad. Okay. All right, hopefully that's pretty clear. So if you guys don't have any questions, we're going to be moving on to for loops. So I actually have a question for you guys. So how do we print out the UCLA A clap chant without using duplicate print statements? Print out A clap without duplicate print statements. So I guess to be more specific, I'm looking for UCLA and then fight. So how do I do this without having like 3 print fight? And the answer is by using a for loop. Hopefully this should be a refresher. So to do for loops in Python, we can do for I in range. And then the number of times we want this loop to run. So in this case, I want my for loop to run 3 times. So I would do for I in range 3. And if I run this cell, I do get UCLA fight. So since I'm not actually using the value of I here, I can just replace this with an underscore, and this will still work. And so, yeah, another question for you guys is, given a list of classes, how do we print out each class in a new line? So let me define the list for us. Okay, so what kind of classes are we taking this quarter? Any suggestions? Okay, CS31, Econ 101, Math 33A. Okay. All right, so how do I print out each class in this list? So one way to do it is by using what we already learned by indexing into a list. So I can do for I in range the length of classes. So this would give me the size of my list. And then I can do print classes sub I. So this would work, but it's pretty verbose if you ask me. So another way we can do this is by using what's called a for each loop in Python. So I can do for C in classes, print C. So the way to read this is for each class in my list of classes, then print out the class. So yeah, we're getting the same thing. And the reason why this works is if we look at range 3. I just can't have to cast this to the list first. So range 3 is really just 0, 1, and 2. So if I actually try to run this again, also print out the value of I each time. So I do get 0, 1, and 2. So that's consistent with what we have down here. So yeah, any questions with regards to for loops or what we did in general? If not, we're going to be moving on to functions. So I have another question for you guys. So if I wrote a cool function that prints out my name 10 times, yeah, I have nothing better to do. And if my friend also wants to print out their name 10 times, then how should we avoid duplicating code? So this is what I have right now. So this would print out Smallberg 10 times. So what I really want to do in this case is convert this little code block into a function. So we can use the def keyword in Python to signify that this is a function. And then we have to come up with like a name for our function. And then its parameters. So it's going to take in name as one of its parameters. And another thing in Python is anything inside a function has to be indented. And I should replace Smallberg with the name that I'm trying to print. So if my friend Sudhanshu also wants to print out their name 10 times, so I can just pass in Sudhanshu here. And this would print out Sudhanshu 10 times. I can also create another variable or parameter in my function, n, which is the number of times that I want the name to be printed out. And if I only want to print out my name like maybe 3 times, then this would be the second parameter. So notice how here we're passing in the parameters into our function by the order in which we define the parameters themselves. So another thing that I could do is pass in the parameters by the name of the parameters. So I can do name equals Smallberg and then n equals 5. So this also works. So I guess in this example, it's not clear why the second case would be like needed. But imagine if you have a function that takes in like 100 parameters, right? So it's going to be pretty hard to remember the exact order in which the parameters appear. So something useful that you can do is passing in the parameters by the names, which is a lot easier to remember. All right. That's all I wanted to cover for this quick little intro to Python, just to get you guys up to speed with the code that we'll be writing for this workshops. So I guess I'm happy to take questions right now. But yeah, this is basically the end of the workshop. I guess I can go back to the slides. My screen is also lagging. Okay. Hold up. Okay, Chrome is just crashing me. Okay, so if one of you guys can share screen, that would be great.
I got you. Yeah.
But yeah, otherwise we'll be covering k-nearest neighbors in our next workshops. Also, please fill out feedback form.
Yeah, thank you guys so much for coming.
And I guess we'll be taking questions.
I have a question. So I saw that you named the list like 1 in your example, but when I tried to do that, it said like you can't assign something to like literal or something. So then I just named
Oh,
it.
sorry, that was an L.
Oh, an L. Okay.
Yeah.
Oh wait, that makes a lot more sense. Okay.
Yeah, because I probably should have named my variables better, but I figured like if the variable only has 1 letter, that's easier for me to type.
Okay.
Yeah,
That makes a lot more sense. Thank you.
Yeah, no problem.